Hey everyone, welcome back. My name's Chris. This is Fully Defined and the SolidWorks by Lego Build and Learn series. This episode, we're looking at the tyre and the wheel. These are two parts that we've done similar versions of before with the off-road buggy. So we do build on an existing model that we already have, but there's plenty of new skills that you can learn. We use the revolve tools. We use some pattern features. We use a move copy bodies and a mirror feature. And then at the end as well, we use some of the assembly tools to find interferences or see where the two parts aren't quite matching up to make some adjustments. So let's jump in.
There we go. All right, so the tie is completely different. There's not much we're going to learn from that one. This one is much simpler. It's probably got the same kind of internal step. Yeah, it's very similar. We'll learn a little bit from the patterning, how that's done on the outside, but this is a much easier shape than this last one that we did. Close that. But this part, compared to this one, you can already see some similarities, right? And some differences. Like this one has a through hole. This one's through and round, whereas that has the axle shape in it, side profile. Similarities. Okay, this has this weird kind of slot through here, and the back detail. Similarities again, but different. So like we'll use this one as some reference, but we'll recreate this, I think. That's a new part. Let's have a look at the Brinkley final, a wheel. We can see here, which look, these are always pretty rough. That's not bad though. All right, so let's just get going on this. So last time we modeled it, this is the process we went through. We did a revolve with quite an amount of detail in it. Now, just for comparison's sake, let's have a look at the dimensions. So this was a 17.4 millimeter diameter when we're measuring. It's very, very close. It's almost identical. And the width, the length of it from the very tip, this was 15. This one, end to end, that's 16, but it's got that extra sort of 1 millimeter on the back. Like from here to here, it's 15. I'd love to cut some corners with this one and use some of this geometry. Because I think we could reuse very quickly some of this stuff here. This was a tricky bit to do. So had these two extrudes coming out to the side, which we then patterned and then used a revolve cut to get that surface down and inside on the face. Like if we have a look at this in detail, what's really interesting about it, you can see these edges here, they drop inside that plastic edge. So it's not smooth. There's actually, there was a bump in the other example of the part. This one, it's almost nothing there. I'm not sure if I could feel it. Maybe this one is different like that. They taper a bit too. Whereas in this one, do they taper? The example that I've got on screen? No, not really. That'd be an interesting tweak. Cut extrude, same. Billet, same. Let's use this and modify it. I'll show you how we go about that. So 55981, save as. Okay, done. Color. So we know what we're looking at, and let's go right back. So when we get a model like this that we're reusing, the easiest way I would like to work with them is to roll back, use the feature rollback button, feature tree rollback, roll right back up. So I'm only dealing with one step at a time. Then if anything changes and I get errors, I can just fix them one at a time instead of have a huge screen of red. Just made it a bit quicker to deal with. So we're going to come in here, and first thing we're going to do is just check some of these dimensions. So it's 17.4 for the diameter. This is close to 17.6, but I'd rather leave it. It's so small, a change. The ring on the front, 7.8. Yep, that's pretty good. That bit in the center, I don't know if I can get to that. No, I can't. So I'm going to stick with the 10 millimeter dimension that you can see there. Then on the outside, that top section, 2 millimeters, yes. The gap, 2, all that looks the same. All of that sort of chamfered edge. This one here, 5 millimeters, 5.8, that's good. This wall, we had a diameter of 14.5. So this one's a bit bigger, 15 point. That means that wall's inner on this one. 1 mil. See this one here had 1.45. You can. All right, so back on the revolve. Now, I think this is all pretty good, except the detail changes at the back, this section, where it doesn't have, like this one has a big solid wall that goes through it, all through the middle. As you can see, it's from the front to the back. Whereas this one's different. What I think I've changed is I remove this and I remove this, and I can join this one up out here. And do I cut hole next? Let's think about it for a second. Like I want a hole going all the way through, which means I can actually move this off, but all my dimensions are coming from that point at the moment. What else? My 17.4, they're coming from this line. So I need to disconnect those two. So I'm just going to bring that out, put this on the origin, make this in line with the origin. Okay, but now I can move this edge independently. So that's a little trick that I found. If you've ever got like two lines like this that are connected and you want to separate them, if I just use power trim on one of them to disconnect, then I can move them independently without having to delete and redo all the relations. So now I can get the hole that's on the inside, which is usual 4.8. I can get that full width, length, which was 15.8. We gave about 15 there. So this is going to stick out 0.8 at the back, and then just put that wall in, and that wall's going to go down into here. And that wall thickness, the outside of that section, 7.8. Oh, matches this. That makes sense. All right, so a neat little edit to the revolve, which means we've now got all of that detail there that we didn't have before. So now this front one's going to fail. That's okay, because I can change that. Don't need that sketch anymore. There is this sort of small recess area in the front, just some 6 millimeters, not unusual. And the depth of that, we're going to guess at 0.8 of a millimeter. So I change this 0.8, and then I'm going to, same on the rear. I can use that sketch, a new extrude cut, but change the sketch face to this one, and then the direction. But I need to resketch or to convert anything. I'm just using the same one in a different place. The yellow color looks a bit funny. Let's see that. Copy. That's the right color. It's just a bit dark. There we go. Very bright. Okay, let's keep rolling down. Now the front detail, that's there. Now I'm noticing in this version, very subtle difference. I think that these taper looks bigger, smaller. Is it? And so it's 3.8 millimeters, but here it's definitely smaller, closer to 3. Cool. So I'm going to edit this sketch. All right, so the changes I just did here, just change a few of the sketches. So these outside lines are now taper in and the inside ones remain horizontal. Sorry, I stuffed up that one. I'll come back to it. So that's going to look better on the pattern now. Are they 1 millimeter? Or are they a bit bigger? A little bit bigger as well. So I'll just bump that up to 1.2. Okay, and then we'll do our pattern cut revolve. Now the cut revolve will change because it no longer looks like it's cutting into the part. That's what I've done here. Okay, great. That is what I've done. It's smooth to the edge. Awesome. All right, that is looking neat. I think the detail on the rear will be the same. Just have to update some lost references. Nothing specific with the hole placement. It should be in line with the prongs, which means this one should be horizontal. And look, be a little bit more spaced out. Is that all the different detail? And then this slot, interesting slot that goes all the way through, but we've got to put that in. Let's roll on the fillet, keep the fillet, and then so on slot is in line with those. So it's going to be from the side that we do this slot, right plane, and it's probably too thin to get in there. Yep. So I'm going to do that by eye. It's up to 7 millimeters, and it's right on those edges. So I'm going to do a rectangle. There's some fillets there which are getting in the way. I'm going to select that face and this face. The rest I'm going to use the origin, right click midpoint, make it horizontal to the origin, and then give it dimension. Extrude through cut through all both. How does that look? Looks a bit thin, if I'm honest. That's 10 millimeters on the outer diameter. I just can't get in there and measure. Maybe the cut's a little bit less, but that's pretty good now. Cut is done. Save. And we're 11:30. I think we've just got enough time to do the tire. Very nice. Let's have a look at the detail of that part. Let's zoom in. Yeah. All right. There's some text. Lego group. You just make it out. It's tiny, right? It's so thin. There is, I think that's a part number. The part number is 89201. Not sure if that matches. Definitely looks like a different number on this one. Anyway, not too worried about that. On the other side, no detail. So internally, it's got this bump goes through the middle. That's what helps it locate on the wheel. And then you've got this tread. That one looks a bit different than the rest. Now it looks a bit deeper. This one tread deeper than the rest. Maybe, definitely. But the rest of it's pretty consistent. So it's obviously staggered left, right. But it's just one level, not multiple levels like the other ones. So what I imagine is we do a revolve of the whole thing. We have to get this dimension right for the middle. We can do one of these cuts, pattern it, do one on the other side, just move the position around and then pattern it as well. And then maybe it's a couple of fillets and it should be done. Let's get into that. The tie that we did last time, just for reference, how we built that. So we started with a revolve. It's a bit tricky with this shape. That sort of internal pit was offset one side. We did a cut revolve for the tread. We did some fillets on that. We did a pattern. Then I split the model. So that bit on the revolve there, that comes back later, I think. Split the model, mirrored, staggered the pattern, combined it back, then added that bump back on, then did some coring, did a chamfer on this front edge, and then finished with the text. This time, it's going to be much simpler in our new part. So front, plane, 2 construction lines. We'll want to get our width. Very important when you're measuring sort of soft parts on the calipers, not to squeeze, right? So just get to contact 14 millimeters. Now I'm measuring to the solid face on the outside. So I'm ignoring the treads. The treads will come in later as a cut to remove material. So this is going to be 14. Oh, that's the wrong dimension. We'll have to fix that now because the wheel diameter, outer diameter, is around 23.6. So this, that is 14. Let's now get that in the middle. Thickness of the outer part of the wheel, 3.2 millimeters. So what I'm going to do is just draw this in, 3.2. I'm going to assume, I'll measure it, that it's the same on both sides. I'm pretty certain that it might even just be 3 millimeters, pretty close. And then that drop in the middle, hard to see, but I can get depth to that. It's probably got an angle to it. It's about 5 millimeters in both sides to a chamfered region. So these sections here are angled. Right, so it's like this. This is also going to be in the middle. So I'm just going to make that coincident. I'm going to make these equal. I've just said that this is about 5 millimeters. And then let's say the diameter at the very middle, and that's 16. So from here to here, 16 looks pretty good. And the angle of that chamfer, let's go 45. And then I'm pretty happy with that. So this becomes a revolve. Okay, and that's the outside of my wheel. And at this point, I will say that 89201, 24 by 14, black. Copy the material, just put it on. There we go. Okay, step 1 done. Step 2 is the tread. So for the tread, you approximately measure that width of the section in the middle, which is very thin. It's a millimeter. And then what's the width of one of these treads? About 2 millimeters. And the depth, I'm going to eyeball that. It's too small to measure, obviously. Let's go to the right plane. And how we're going to do this, we're going to convert the edge for the depth. We're going to offset it. It's not much. It's tiny, 0.5 millimeter. Reverse that. The thickness, we're going to assume that it's in line with the center. So, how to do this? Front, 2 lines, trim them. You just put a construction line in. It might be the easiest way. What I want to do is just get them all symmetrical, right? So that then I can go from here to here and say that that's going to be, I measure 2 millimeters. The lines themselves, each line in line with the origin, trim the outsides. Okay, and so there's our section that we're cutting. Then we're going to go extrude cut. The width is 14. The width of the middle section is 1 millimeter, but we're going to go halfway. So we're going to go 14 divided by 2 minus 0.5, 6.5. And then, does it have any, fillets or anything on that edges in those sort of internal quarters? Maybe a very tiny one, like in there, and probably on this outside edge. So we'll put those in at some point as we do this pattern. What I want to do is mirror this, because now I'm thinking about how to do this tread. So how many are there? How many patterns are there? I found this always very difficult. Put my finger on one of them and count. So starting at 1, 2, 3, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 treads. So I want to move. Need to think about this. This is where splitting it and just rotating it seemed to make a lot of sense last time, because I want to do a feature pattern, but if I move a face, that's going to cause me problems. So I think we'll just rotate it afterwards. So we're essentially here doing the same thing I did on the other tread. It's just that the whole design's a lot simpler. So I'm going to do half the wheel, right? I'm just doing half. I'm going to grab that, then come back there. I'm going to grab those two, and I'm going to do my circular pattern, and we've got 20 of those. And I'm going to mirror this body, but I'm not going to merge it, and I'm going to rotate. So I'm going to select this body. I'm going to translate, rotate. Yeah, exactly, Arte. That's what I do for this. And that's how I did the last wheel. So now I'm going to rotate it. And because the origin's right in the middle, it makes it really easy. So I'm rotating around. I always look to where my head isn't right now, where the axis is. So I'm rotating around the X. Now I want to rotate, there's 20 instances. So 360 divided by 20 divided by 2 to stagger them. All right. So now they're halved. Then I combine them back together. You know, it's funny color on this one. I don't know why, but yeah, that is done. But I haven't put the fillets in. And so I probably want to put that other fillet in before I do the mirror, at least. Before I do the cut here, I want to put this fillet in. This fillet's going to remove my edge. So there's a fillet on this edge, which we're going to put at like 0.5 millimeter. It's going to cause an issue with this cut extrude because I've lost, that face. There's 2 sketches here now. I'm just going to convert that. And this one can sit on this edge. Does that make sense? Yep, close enough. Okay, done that. Done that. Also, I want to put radius on that edge. Yep. And I need to include this fillet. Okay, that worked. And then that should be okay now. Something funny with the materials. Make a sketch and measure the angle. I'm not sure which angle you're talking about. I'm pretty happy with the finished tire though. What we can do now is check how it fits against the wheel. Right? So let me just fix this one temporarily. And we'll do a mate of these two and then face to face. That is the wrong face. I want to do this face. Yeah. So my sizing's a little bit off with these two. Something's going wrong, but we can tweak that. So the inside of my wheel is a tiny bit small. So what's wrong on this one? Maybe the tire. So I'm going to edit the tire. I'm going to just go force transparency. The wheel, or what's the wheel diameter? I think it was 17.4. So if I'm on the tire, I want to go in the revolve and let's drop that down to 3. It's too big. 3.1 is the right size. Cool. You can see how those two parts kind of fit there. Perhaps this needs to get a tiny bit bigger. So it's fitting inside. That looks a lot better. And the length of the wheel looks a little bit off. I did measure it at 14, which is still correct. So maybe the tire outside edge should be 14. I think I need to change that one. Not the tire, sorry. This bit, the wheel, if I have a look at that, and the length of that revolve, I've got 15 there. I think that needs to drop down to 14. Is that okay or not okay? So that 14 dimension is not quite the full width. Let me put that back to 15 and just to measure what it's missing. Those two there, it's 0.4. So I'm going to change this revolve here, reduce that by 0.4. That should be enough to get a nice fit. Cool. Those are looking pretty good, but the middle looks a bit off now. So I might want to fix that. That's in my tire. What's more likely to be different, the yellow plastic or the tire? Probably the yellow plastic. It's not quite centered on that 14.6 because it should be centered on this. I think that's the one. Yep. All right, that's better.
Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.